Mr. Cleon here from Cleon Maths. Today we're going to be looking at partial fractions again, and we're going to look at type 2 today, which is the repeated linear factors in the denominator. Let's just jump straight in. So we're looking at ones in this form where we've got some sort of fraction where in the denominator is maybe like x plus 3 squared, or maybe x plus 3, x plus 3, x plus 3, x plus 3 cubed, as long as it's repeated. If that happens, the form that the partial fractions will take will be, as you can imagine, a over x plus 3 plus b over something. Now, it can't be b over x plus 3, and the reason for that is if it was, then you could just straight away add it would be a plus b over x plus 3, which makes no sense. So I'm going to have to get it squared, so I'm going to need x plus 3 squared as well. So that's what the form is going to take, a over x plus 3 plus b over x plus 3 all squared. And then we do it in exactly the same way. If we were to add these together, then I would need to times this fraction by x plus 3. So that implies I would have a times x plus 3 to make a common denominator on the bottom, x plus 3 squared for this. But this one doesn't have to be times by anything because it's already got x plus 3 squared. So it would just be plus b. And that would now equal the whole top x plus 4x plus 2. Multiplying my brackets out, I get ax plus 3a plus b equals 4x plus 2. And there you can see in this simple example, there's only one coefficient of x, so straight away that implies that a must equal 4. And we've got 3a plus b equals the numerical number 2. But we know a is 4, so 3 times 4 plus b equals 2. 12 plus b equals 2 implies b must be negative 10 in this case. So our partial fractions become 4 over x plus 3 minus 10 over x plus 3 squared. Let's just double check our answer to make sure that actually adds up to what we originally got. So if I times this one by x plus 3, which is all I need to do, I get 4x plus 12, and then take away 10, which is 4x plus 2, so it's definitely correct. Okay, example 1, expressing partial fractions x plus 3 over x minus 2 squared. So our first starting point is to write x plus 3 over x minus 2 squared equals a over x minus 2 plus b over x minus 2 all squared. We then go ahead and do our partial fraction. So remember, this one is the only one that needs to be times by anything. So we get a x minus 2 to make the common denominator, plus b, because that's already got x minus 2 squared in it, and that equals the numerator x plus 3. So ax minus 2a plus b equals x plus 3. Straight away we can see that the coefficients of x implies that a equals 1 because we've got a here and we've got 1 here, and then we've also got minus 2a plus b equals 3. So that means that we've got minus 2 times 1 plus b equals 3, minus 2 plus b equals 3, or b equals 5. And we're done. So that means that our final answer, just put it back up the top, is 1 over x minus 2 plus 5 over x minus 2 all squared. Okay, slightly harder one. Express this in partial fractions. So we've got 3x squared minus 11x plus 5 all over x minus 2, x minus 1 squared. So that means we've got a over x minus 2, no problem there, plus b over x minus 1, plus c over x minus 1 squared. Do not be tempted to do a over x minus 2 plus b over x minus 1 squared. That won't give us the correct answer. We need that b over x minus 1. So then being very careful, let's have a look at this. A over x minus 2, that needs to be times by x minus 1 squared. So that means that this one gets times by this one. So we get on the top a x minus 1 squared. This middle one only has to be times by x minus 1. So b times x minus 1. But also has to be times by x minus 2. And the last one, c, well, c's denominator is x minus 1 squared. So we also just need an x minus 2. So that is our top, and that equals, of course, remember, 3x squared minus 11x plus 5. So if we choose values for x, we can eliminate a and b straight away. If we choose 1, then that bracket is 0, and that bracket is 0. So let's just write that down. Let x equal 1. Then we get a times, I'll just write this out longhand so you can see it, 1 minus 1 squared plus b times 1 minus 1, 1 minus 2, plus c times 1 minus 2 equals, x is 1, remember, so 3 times 1 squared minus 11 times 1 plus 5. But we can see clearly 1 minus 1 is 0, so that is 0, that's gone. And 1 minus 1 is 0, so that's gone, leaving just c times 1 minus 2, which is minus c, equals 3 times 1 is 3. 3 take away 11 is negative 8, plus 5 is negative 3. Or to put it another way, c equals 3. So we've got our c value straight away. Let's go back and see if we can do the same thing to get an a or a b. Well, if we choose number 2 now this time, it will eliminate this one and this one. I won't write it out the whole way now this time, but if I let x equal to 2, you should be able to see that you've got a times 2 minus 1 squared. And the middle one, that's 0, so that's gone, and this is 0, so that's gone. So that just equals the right-hand side, where x is 2, so 3 times 2 squared, minus 11 times 2, plus 5. We can work that out. 2 minus 1 is 1, square that is still 1, so that means that a must equal the answer to this sum. 3 times 4 is 12. 12 take away 22 is negative 10. Negative 10 plus 5 is negative 5. So a is negative 5. So we've got our a and our c. We now just need to get our b somehow. So let's go back up. So we can't pick the numbers 1 and 2 because we've already done that, and that will eliminate b. But since we already know a value for a and b, c, we can just pick any number for x, and that will allow us to then get an equation to work out b. So let's just pick the next logical number, which is 3. So if I write let x equal 3. So if we let x equal to 3, we get a times 3 minus 1 squared plus b times 3 minus 1, 3 minus 2, plus c times 3 minus 2 equals 3 times 3 squared minus 11 times 3 plus 5. So we can expand that. So that means we get 3 minus 1 is 2, 2 squared is 4, so we get 4 times a. Then we've got 3 minus 1 is 2, 3 minus 2 is 1, so it's 2 times 1, which is 2, so plus 2b, and plus c is equal to 9 times 3 is 27, 27 minus 33 is negative 6, negative 6 plus 5 is negative 1. But we know that a is minus 5 and c is 3, so that means we've got 4 times minus 5 plus 2b plus 3 equals minus 1. So we've got minus 20 plus 2b plus 3 equals minus 1, or minus 17 plus 2b is minus 1. So 2b is minus 1 plus 17. 17 minus 1 is 16. And therefore, b equals 8. And therefore, we can say that our original thing, 3x squared minus 11x plus 5 all over x minus 2, x minus 1 squared, minus 5 over x minus 2 plus 8 over x minus 1 plus 3 over x minus 1 squared. Or to make that look a little bit nicer, because we've got a negative fraction coming first, we could say 8 over x minus 1 minus 5 over x minus 2 plus 3 over x minus 1 squared. And we're done there. Example 3 says express this in partial fractions. So we've got 16 over x squared minus 2x minus 3 times x minus 3. That is not a linear factor. We have not done any ones without linear factors, so we need to factorise the denominator first. So that gives us 16. I'm just going to go straight away into our factorisation. Double brackets times x minus 3. We've got x and x. It must be 3 and 1. Minus 3. And then we've got plus 1 to get minus 2 in the middle. So that must then equal a over x plus 1 plus b over x minus 3 plus c over x minus 3 squared because of a repeated factor. And then we can go ahead and straight away do that. So that implies, if we look at our first term, x plus 1, we need to times that by x minus 3 squared. So we're going to get a times x minus 3 squared plus b times, well, that's already x minus 3, so it needs another x minus 3 and an x plus 1. And c just needs, it's already got x minus 3 squared, so it just needs an x plus 1. That gives us our numerator, and that equals just the number 16. And then we can do the same thing we always do, pick values for x, but eliminate a bunch of them. So very quickly with this one, if I let x equal 3 to start with, you should be able to see this by now. That goes, leaving just this one. 3 plus 1 is 4. We get 4c equals 16, or c must equal 4. Nice and simple there. We can pick another value for x. We could pick the number -1. If we do that, you can see that this goes and this goes, leaving just a minus 1 take away 3 is minus 4. If we square that, you get 16. So you get 16a equals 16, or in other words, a equals 1. And then we can pick any other value for x to get our last number. So we might as well just pick an easy number. Let's just pick the number 2. But any number will do. So if x is equal to 2, we get a times, well, 2 minus 3 is minus 1. Square that is 1, so we'll just get a. Plus b times, well, 2 minus 3 is minus 1. 2 plus 1 is 3. And then we get c. 2 plus 1 is also 3. And that equals 16. But remember, we know our values for a, b, and c. A and c. We've got 4 and 1. So a is 1. This will be minus 3b. And c is 4. So plus 12 equals 16. 12 and 1 is 13. So we've got minus 3b equals 3. Just taking the 13 over. And therefore b must equal minus 1. And we're done. We've got our a, b, and c, so we can then write it as partial fractions. So therefore, we can say that 16 over our original thing, which was x squared minus 2x minus 3, times x minus 3 equals, and just putting it nice and neatly again, so putting our -1 in the middle, 1 over x plus 1 minus 1 over x minus 3 plus 4 over x minus 3 squared. Okay, a quick past paper question to finish us off on this. So this comes from 2019, paper 2, question 1 of the advanced higher maths paper, and it says express x squared minus 6x plus 20 over x plus 1x minus 2 squared in partial fractions. So you notice the repeated linear factor. So we can say that we've got x squared minus 6x plus 20 all over x plus 1, x minus 2 all squared equals a over x plus 1 plus b over x minus 2 plus c over x minus 2 all squared. So that implies that we've got, if multiplying through the first one, x plus 1 gets times by x minus 2 squared. So we've got a x minus 2 squared plus b, that gets times by x minus 2 and x plus 1. And c gets times by x plus 1. That equals our left-hand side numerator, which is x squared minus 6x plus 20. So then we just need to pick our values for ax. So let's just pick 2 to start with. Let x equal to 2. That eliminates the first one and the second one, leaving 2 plus 1 is 3. So 3c equals, substituting 2 into the right-hand side, 2 squared minus 6 times 2 plus 20. So 3c equals 4 minus 12 is negative 8 plus 20 is 12 again. So in other words, c equals 4. So now we can let x equal another number. We're going to pick minus 1, of course, because that will eliminate the brackets with x plus 1 in them, leaving just this one. So minus 1 take away 2 is minus 3. All squared is 9. So we get 9a on the left-hand side. And on the right-hand side, we get minus 1 squared, which is 1. Minus 6 times minus 1 is plus 6 plus 20. Or in other words, 9a is equal to 27. And therefore, a is 27 divided by 9, which is 3. Then we just pick any other number we want to get our final letter b. So we might as well, we've picked 2 and minus 1. We might as well just pick 1. That'll be a nice and easy number. So let's let x equal to 1. So if we do that, go back up, we will get 1 minus 2, which is minus 1 squared, which is 1. So we'll get 1a plus 2. 1 minus 2 is minus 1. So 2 times minus 1 is minus 2. So we'll get minus 2b. So that's actually a minus. And then for our last one, we've got x plus 1. 1 plus 1 is 2. So we'll get 2c. Equaling the right-hand side. So substituting 1 into this, we get 1 minus 6 is minus 5, plus 20 is 15. But remember, we've already got our values for a and c, they are 3 and 4. So we've got 3 minus 2b plus 2 times 4 is 8 equals 15. 3 plus 8 is 11, so minus 2b plus 11 equals 15. Or minus 2b equals 4. And therefore b is equal to minus 2. A was over x plus 1, so 3 over x plus 1. Minus 2 over x minus 2. And our c value was 4, so plus 4 over x minus 2 squared. And we're done there. This has been Clever Maths, and today we've looked at partial fractions where in the denominator it's a repeated linear factor. Take care, stay safe, and goodbye.